Hence, sigma bond is stronger in comparison to pi bond, because in pi bond, the extent of overlapping is happening in a smaller extent. Atoms of same element will be having same properties. Atoms of different elements will have different properties. The reaction is happening and the temperature is increasing, means what will happen to the equilibrium? According to Le Chatelier's principle, the system will try to now decrease the temperature. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. So today I'm back with session 2 of the model question paper discussion. So in the last session, we discussed part A and part B of the model question paper, that is 1 mark and 2 mark questions. So in today's session, we are going to completely discuss part C of the question paper, that is 3 mark questions, right? Okay, answer any 3 of the following. Each question carries 3 marks. Okay, so out of the given questions, any 3 you have to answer. So each question will carry 3 marks. 3 you are attending, so 3 into 3 you will get 9 marks from part C. Okay, so let's begin with the first question, that is question number 30. Define electronegativity of an element. How does it vary along a period and down a group in the periodic table? So the first part says define electronegativity of an element. So what is electronegativity? We already know that electronegativity is a measure of an atom's ability to attract shared pair of electrons towards itself. So what does that mean? So let's take an example of HF. Okay, so this pair of electron, that is these 2 electrons, as of now is shared between the hydrogen and fluorine atom, right? So here, as fluorine is more electronegative, it is having an ability to attract this shared pair of electrons towards itself. So comparing with hydrogen, fluorine is more electronegative. And in general also, fluorine is the most electronegative element in the whole periodic table, right? So as fluorine is highest electronegative element, what happens? The shared pair of electrons, this is in equal distance, it is supposed to be, that is equally, it is supposed to be shared between hydrogen and fluorine. But as fluorine is more electronegative, it has an ability to attract the shared pair of electrons towards itself. So what happens then? Fluorine will get a partial negative charge because it is attracting electron, right? And hydrogen will get a partial positive charge. So this is called as electronegativity, right? That is, it is an ability of an atom to attract the shared pair of electrons towards itself. So this was shared, this pair of electrons is being attracted towards the more electronegative element, right? Okay, now the next part, how does it vary along the period and down the group? So on the periodic table, electronegativity generally increases as you move from left to right. So across the period, what happens? It increases, and across period decreases as you move down a group. Okay, as you move down the group, the electronegativity decreases. So this is the 30th question. Moving on to the next one. Explain the shape of ammonia molecule using VSEPR theory. So what is VSEPR theory? Valence shell electron pair repulsion theory. Yes, so this theory is based on the repulsions which is happening between electron-electron pairs, right? So you have to explain the shape of ammonia. What is ammonia? NH3, right? So we are going to explain the shape of ammonia using VSEPR theory. So it is given there which theory? We have studied valence bond theory, VSEPR theory, as well as molecular orbital theory, right? So it is given using VSEPR theory, you have to explain. So let us see. In ammonia, central nitrogen atom has 5 electrons in its valence shell. It shares 3 of its electrons with hydrogen atom to form 3 bonds, and remaining 2 electrons are present as lone pair. So what does it mean? Nitrogen, okay, nitrogen, we know the atomic number is 7, right? That means it is 2, 5. That means in the valence shell, how many electrons are there? 5 electrons are there, right? So 1, 2, 3, 4, 5. Total of 5 electrons, right? Now, these 3 electrons that you can see here, it will be shared with another hydrogen atom. That is one hydrogen, another hydrogen, another hydrogen. So it will form 3 bond pairs, right? 3 bond pairs. So these 3 electrons are already taking part in bond formation. Now there are other 2 electrons, total 5 are there, other 2 you can see here. Now this is called as a lone pair, right? So this is how the ammonia molecule will be formed, right? That is, the 3 electrons of nitrogen will take part in bond formation, and the other 2, which is 1 pair, will be present as the lone pair. Okay, since nitrogen has 4 electron pairs around it, it should adopt tetrahedral geometry. Okay, so we can predict the geometry based on how many number of electron pairs are there, right? So you can see here 1, 2, 3. 3 bond pairs are there and 1 lone pair is also there, right? 1, 2, 3. 3 bond pairs and 1 lone pair is also there, right? So 3 bond pair and 1 lone pair will give you a total of 4 electron pairs. Okay, there are a total of 4 electron pairs. So if a molecule is having 4 electron pairs, it is supposed to have which geometry? Tetrahedral geometry. But according to VSEPR theory, what happens? There will be electron-electron repulsions which is happening, right? So as you can see here, there will be lone pair, bond pair repulsion as well as bond pair repulsion, right? So as we already know that the lone pair, bond pair repulsions is greater than bond pair repulsion. So what happens? This repulsion will be more than the repulsion between these bond pairs. Hence what happens? Yes, the angle will become much more less, right? So due to the presence of lone pair in nitrogen, geometry is regarded as pyramidal geometry with bond angle 107 degree. Tetrahedral geometry means it is supposed to be 109.5 degree, but because of this repulsions, that is lone pair repulsions and bond pair repulsions which is taking place, the angle is reduced to 107 degrees, right? So this is the shape which is pyramidal geometry. I hope it is clear. So this is the shape of ammonia molecule using VSEPR theory. So this much you have to explain in detail with the structure which is given here. Okay, so the angle will be 107 degree. So these 3 are the bond pairs and this is the lone pair which is represented here. Moving on to the next question, define dipole moment. What is its unit? Okay, that's the first part. Second part is sigma bond is stronger than pi bond. Give reason. Okay, so the first question, dipole moment is defined as the product of the magnitude of charge and the distance between the center of positive and negative charges. Okay, so dipole moment you have studied in physics as well, right? The two charges which is separated by a distance, right? So how do you calculate the dipole moment? It will be the magnitude of those charge multiplied by the distance of separation between them, right? Okay, so let's take the example of HF itself. As discussed, because of the electronegativity, fluorine will be having a partial negative charge, hydrogen will be having a partial positive charge. So this is a dipole and a dipole moment will be existing here. How do you calculate the dipole moment, which is represented by the symbol mu, right? It is the charge, right? Charge on the atom multiplied by the distance of separation, multiplied by the distance of separation. Okay, so that is dipole moment. What's the next part? What is its unit? Its unit is coulomb meter. Why it is coulomb meter? Charge, unit of charge is coulomb. Unit of distance is what? Meter. Right, another unit is dBA, right? dBA is also the unit for dipole moment. Now the next part, sigma bond is stronger than pi bond. Why it is? Let's see. The strength of a bond is dependent on the extent of overlapping. Okay, the strength of the bond is dependent on the extent of overlapping. If the extent of overlapping is more, we can say that the bond is much stronger. So considering sigma bond and pi bond, which will be having more extent of overlapping, it will be sigma bond. Let's see, in the case of sigma bond, the overlapping of orbitals takes place to a larger extent. Hence, sigma bond is stronger in comparison to pi bond. Because in pi bond, the extent of overlapping is happening in a smaller extent. So, let's take the example of two p orbitals. If it overlaps like this is called as head-on overlapping, right? This is head-on overlapping or axial overlapping where a sigma bond is formed. So, much more overlapping or the extent of overlapping is more in this case. Now, let's take the sideways overlapping, which is called as a pi bond. A pi bond is formed here. As you can see, the extent of overlapping is less here. So, comparing these two, extent of overlapping is more in sigma bond. Hence, sigma bond is much more stronger. So, I hope it is clear. Right. Moving on to the next question. Write Lewis dot structure for NO2 minus molecule. calculate the formal charge on each oxygen atom present in it. Okay, so first part is we have to draw the Lewis dot structure for NO2 minus. Okay, so we know that which are the atoms present here, nitrogen and 2 oxygen atoms are present there, and you have a negative charge. So what is the first step that you have to do to draw the Lewis dot structure? We have to calculate the total number of electrons which is present, right? So NO2 minus. So in nitrogen we have a total of 5 valence electrons, right? 5 we are having, and in oxygen the number of valence electrons is 6, right? And how many are there? 2 oxygen atoms are there. So 6 into 2 will give you 12. And also you have a minus charge here. That means one extra electron is also present. So that will give you plus 1, right? So that will give you a total of 18 electrons. So a total of 18 electrons are present in this NO2 minus molecule. So that is the first step to do to calculate the total number of valence electrons. Now let us consider nitrogen and oxygen is there. So nitrogen will be the central atom. So we write nitrogen in the center, 1 oxygen here, 1 oxygen here. And then we have to put single bonds, right? So 1 single bond here, 1 single bond here. That means already 4 electrons have taken from the 18 electrons. That means in this NO2 minus molecule, a total of 18 electrons should be there. So already 1, 2, 3, 4 I have used, right? Now still 18 are there. So already 4 used means still 14 I have to fill, right? So let's see, 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13 and 14. Okay, so 14 electrons are completely filled. Now what we have to see, that is a total of 18 electrons are there, right? So now what is the next step that we have to do? We have to see whether each atom is able to attain its octet, right? So let's see for this oxygen atom, 1, 2, 3, 4, 5, 6, 7, 8, right? For oxygen atom, okay. 1, 2, 3, 4, 5, 6, 7, 8. For this oxygen atom is also okay. Now for nitrogen, you can see 1, 2, 3, 4, 5, 6. Only 6 is there. So what happens? One single bond, that is one lone pair, can become a double bond. So let's assume this lone pair is getting shifted here as a double bond. So what will be your structure? 1, 2, 3, 4, 5, 6. So this will become a double bond here, and you have the nitrogen, 1 pair of electrons is there, 1 lone pair is there, and single bond 1, 2, 3, 4, 5, 6. Now let's count for the nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. So everyone is getting 8 electrons in its outermost shell. And what is a very, very important part to remember? There is a minus charge also. So we have to represent that as well. So this is the structure. Okay. So I hope it is clear. So how do you calculate? First you have to calculate the total number of valence electrons. For nitrogen it is 5, oxygen it is 6, 2 oxygen is there. So that's why I have written 12 there. And minus charge is there, which stands for 1 extra electron. So total 18 electrons are there. Then we represent the atoms, then put single bonds, and then we start filling the number of electrons, which should be equal to the total number of valence electrons, right? And then we have to see for each atom whether the octet is completed, and based on that we have to make the necessary adjustments. That is, the lone pair has to be made into a double bond. I hope it is clear, and the charge should be represented. So this is the Lewis dot structure for NO2 minus. So now the next part is calculate the formal charge on each oxygen atom present in it. So let's consider this as the first oxygen atom, this as the second oxygen atom. Only for oxygen atom they have asked. So no need to calculate the formal charge on nitrogen. So let's calculate for the nitrogen atom first. Even though it's not asked in the question, let's see how to calculate how the formal charge on nitrogen atom is calculated. Okay. So the number of valence electron on nitrogen atom is 5, right? The number of valence electrons on nitrogen is 5, and number of lone pairs is 2 electrons. So as you can see here, how many lone pairs are present here? Only 1 lone pair is present, right? So these 2 is a part of this bond, and this one is a part of this bond. Only this is present as lone pair. So 1 lone pair means how many electrons are there? 2 electrons are there, right? So lone pair of electrons is 2. Now number of bonding electrons is 3 into 2, that is 6 electrons. As you can see, this is 1 bond, another bond, another bond. So the total 3 bond pairs are there. So 3 into 2, 6 electrons will be there, right? So 6 electrons, right? So now what is the equation for formal charge? Calculation of formal charge, it is total number of valence electrons minus total number of lone pairs of electrons in the atom minus half of total number of bonding electrons, right? So as you can see here, 5 that is total number of valence electrons. So let me write the equation here. Formal charge is equal to number of valence electrons minus total number of lone pair of electrons minus half of total number of bond pair of electrons, right? So it's very important. It is not the bond pair or lone pair. It is lone pair of electrons, bond pair of electrons. So you calculate the number of how many lone pairs or bond pairs is there, multiplied by 2 you have to do. So I hope it is clear. So for nitrogen atom, let's see, number of valence electrons is 5. Total number of lone pairs we already calculated is only one lone pair. That means how many electrons are there? 2 electrons, right? Minus 2 minus half of bond pairs, 3 bond pairs are there. That means 3 into 2, 6. So that will give you 0. Right? Clear? Now moving on to the first oxygen atom, which is marked this one. Okay. So let's calculate number of valence electron on this oxygen atom. Valence number of oxygen atom is always a constant. It is 6, right? So now let's calculate the formal charge on the oxygen atom, which is marked 1. Okay. So in here, this is the first oxygen atom. This is the second oxygen atom. So for this one, we are going to calculate the formal charge. So of course, the valence number of electrons in oxygen atom is 6. Now the next point to calculate is lone pair of electrons in oxygen atom. How many lone pairs are there? 1, 2, 3 and 4. 4 electrons are there, right? So 2 lone pairs means 4 electrons. Now what is the number of bond pair of electrons which is formed? As you can see here, this oxygen atom takes part in 2 bonds, right? Okay, that means 2 bond pairs means 4 electrons, right? Again 4 electrons. Now substituting in the equation, total number of valence electrons is 6 minus total number of lone pair of electrons, that is 4, minus half of bond pair of electrons is 4, which again gives you 0. Okay, so that is also clear. So now moving on to the next oxygen atom, that is this oxygen atom. Let's calculate. The number of valence electrons is again 6. Then number of lone pair of electrons, as you can see, 1, 2, 3, 4, 5, 6. 6 lone pair of electrons are there. Right, as you can see, 1, 2, 3, 4, 5, 6. Now, how many bond pair of electrons are there? Only one bond is here, right? One bond means 2 electrons, right? Okay, so that is given here. Valence number of electrons is 6, number of lone pair of electrons is 6, and number of bond pair of electrons is 2, right? Now, substituting in the equation, 6 minus half into 2 will give you minus 1, right? Minus 1. Hence, the sum of formal charges, that is a net charge on NO2 minus is minus 1. So, from this formal charge, what did we actually understand? There are 1 nitrogen atom and 2 oxygen atom. And so, which oxygen atom is exactly contributing this minus charge, we were able to calculate. That is, the second oxygen atom is the one which contributes the minus charge. So, that is why the total charge on NO2 minus is minus 1. That is the negative charge which is represented here. So, I hope it is clear. So, you have to calculate the total number of valence electrons, number of lone pair of electrons, number of bond pair of electrons, and substitute in the equation which is given here. So, I hope it is clear. Moving on to the next question. Balance the chemical equation by oxidation number method in acidic medium. So, this is a very important question. Okay, so balancing of chemical equation, that is redox reactions, can be done in 2 methods. That is, one is oxidation number method, another one is ion electron method, and it can be done in acidic medium as well as basic medium. So the question here, or mostly the question which is asked in your question paper, is using oxidation number method and acidic medium. So let's move on to the question. That is, Fe2 plus MnO4 minus gives Fe3 plus Mn2 plus. So this is the redox reaction given here. So what is the first step to do? We have to write the skeletal equation. So what a skeletal equation means? That is, if there is any H2O or OH minus any other substances are present, we have to just remove that and just write the equation like this. So this is already a skeletal equation which is given there. There are no other water molecules which is present here. Right. So now the next step. What is the next step? We have to identify the oxidation number in each of these atoms. Right. So oxidation number we have to calculate, and then we can identify which is undergoing oxidation and reduction. So coming on to MnO4 minus. Of course, in Fe2 plus, what is the oxidation number? It is easy to calculate. Whatever is the charge, that is the oxidation number. Now in MnO4 minus, let us calculate. MnO4 minus. So for manganese, I don't know the oxidation number, I take it as X. For oxygen, we know that it is -2, right? For one oxygen atom, it is -2. How many oxygen atoms are there? 4 are there. So that means 4 into -2 will be equal to -1. There is a whole -1 charge, right? So X minus 8 is equal to -1. X is equal to, we take this 8 other side, it becomes +7. So the oxidation number on manganese will be +7. Iron we already discussed, it is +2. Right. Now moving on to here also it is simple. Whatever is the charge, that is +3, that is oxidation number. Here also it is +2. So this is an easy question. Only you have to calculate for one molecule what is the oxidation number. Rest whatever is the charge, that is exactly what you are going to use here. Right. So now we calculated the oxidation number as +7, +2, +2 and +3. Now what is the next step? We have to identify which is undergoing oxidation and reduction. So oxidation is the one which undergoes an increase in oxidation number, and reduction means there will be a decrease in oxidation number. So manganese, here it is in +7 oxidation state, here it is in +2 oxidation state. So that means it is decreasing by 5 units, right? It is decreasing by 5 units. So it is decreasing means it is undergoing reduction, right? Now iron, it is in +2 oxidation state here and +3 oxidation state here. So it is undergoing an increase in oxidation number. So it is undergoing oxidation. So by how many units? By 1 unit it is undergoing an increase, right? From +2 to +3, right? 1 unit. From here +7 to +2 means 5 units. Now we have 5 units here and 1 unit here. Now the next step is to make this unit change same. That means if it is 5 units, I need 5 units there also. So what is the easiest method to do? I have to multiply this particular equation, that is Fe2 plus 2 Fe3 plus 2, 5. So what happens? The unit change will be 5 here as well as 5 here. Okay. So let us write down that equation here, that is MnO4 minus 2 Mn2 plus 5 units changes there, nothing to change there. Now we have Fe2 plus 2 Fe3 plus. Okay, that is 1 unit change. So what happens if we have to make both of them equal? I have to multiply this by 5. Okay, so now let us add these two equations and write together MnO4 minus, now what happens to the Fe2 plus? I have to multiply it by 5. So it becomes 5 Fe2 plus gives, right? Mn2 plus is already there on the product side. Then you have 5 Fe3 plus. So that is what is shown here. MnO4 minus plus 5 Fe2 plus gives 5 Fe3 plus Mn2 plus. So this much you are clear. I hope so. Now what is the next step to do? We have to balance the number of, see, all other atoms are balanced. You have 1 manganese here, 1 manganese here. 5 iron here, 5 iron here. All the other atoms are balanced. Now something else is pending. Oxygen and hydrogen atoms we have to balance. So now we are only having oxygen atom here. That's the next step we have to balance. So let me write down the equation once again. MnO4 minus plus 5 Fe plus 5 Fe2 plus gives Mn2 plus 5 Fe3 plus. So this is the equation that we have got, right, by balancing all other atoms. Okay. Now what is the next step to do? We have to calculate the number of oxygen atoms which is present. So of course you can see there are 4 oxygen atoms present on the reactant side. So do you have any other oxygen atoms present anywhere else? No, right? So if I have to balance the number of oxygen atoms, I have to do that using water molecules. Okay. So we have to add water molecules to the side, that is whether the reactant side or product side. We have to add the water molecules to the side which is deficient in oxygen atoms. So you have 4 oxygen atoms here. So I need 4 oxygen atoms on the product side, which I have to add using water molecules because it is acidic medium, right? So 4 water molecules I have added. Okay. So now let's see, oxygen atoms 4 here, oxygen atoms 4 there. As you can see, 4 oxygen atoms. But there is another problem. Hydrogen atoms also came into existence here. How many are there? 4 into 2, 8 H plus ions is also there. Right. So now to balance that, what do? I add 8H plus here. So now let's see, 8H plus here, 8H plus there, 4 oxygen atom here, 4 oxygen atom there. So this is your final balanced chemical, that is redox equation, that is 8H plus MnO4 minus plus Fe2 plus gives Mn2 plus 5 Fe3 plus 4H2O. Okay, so I hope it is clear. Because it is acidic medium, we have to balance using H plus ions. Now if it is basic medium, we have to balance using OH minus ions. So I hope the steps are clear for you. First we have to assign the oxidation number. Okay, then we have to identify which is undergoing oxidation and reduction, and by how many units it is undergoing oxidation and reduction. So based on that, we have to multiply whichever factor we have to. Here we have multiplied it by 5 for the second equation. Then we obtain an equation. To that we have to see or balance the number of oxygen and hydrogen atoms, which has been done here. Okay, so if you find the number of oxygen atoms in reactant side, for example, we have to balance it by adding water molecule to the product side. Okay, if it is more in product side, we have to add it to the reactant side. So once oxygen atom is balanced, then we have to balance the H plus ions also. So this is the final redox equation, balanced redox equation. I hope it is clear. Moving on to the next question. Answer any three of the following. Each question carries 3 marks. So out of the questions that we are going to discuss, any 3 you have to do. Again, yes, you have 3 into 3, 9 marks. So in that is the fourth section. It was the same. 3 questions you have to attend. Out of the questions we have discussed, you will get 3 marks for each question, that is 9 marks, and from here you get 9 marks. Let's discuss the first question. Write any 3 postulates of Dalton's atomic theory. So there are various postulates for Dalton's atomic theory. I have also mentioned 6 here. So only any 3 is required. So any 3, if they have mentioned any 3 only you have to write. Each will carry 1 mark. Okay. So let's discuss those. All matter is made up of tiny particles called as atoms. Right. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Okay, atoms can neither be created nor be destroyed. Now, atoms of a given element are identical in mass and chemical properties. Atoms of different elements have different masses and chemical properties. Atoms of same element will be having same properties. Atoms of different elements will have different properties. Now, atoms combine in the ratio of small whole numbers to form compounds. Atoms will be combining to form compounds which will be in small whole number ratio, right? The last one is relative number and kinds of atoms are constant in a given compound. So, any 3 of this you can write and you will get 3 marks. Moving on to the next question. Write any 3 limitations of Bohr model atom. Okay, Bohr model of atom, you have to write any 3 limitations. Okay, each limitation will carry 1 mark. Okay, so it is very important to write proper sentences, that is proper limitations, and very important limitations also. So random limitations will not carry the marks. So you have to specifically write the limitations for each of the theory. So here it is given Bohr model of atom. It can be Rutherford model of atom. Write the limitation for Rutherford model of atom, or else Thomson model of atom. Right. So specifically for that model of atom, what is the limitation? You have to specifically mention it. That will carry marks. Okay. So it could not explain the spectra and energy of atoms containing more than 1 electron. For 1 electron, that is hydrogen and hydrogen-like species, there was an explanation, line spectrum, everything was discussed. But for the atoms which is carrying more than 1 electron, right, what happens? There was not a proper explanation given. That's the first one. Bohr's model could not explain the reason why atoms should combine to form chemical bonds and why molecules are more stable than their constituent atoms. Right. Next one. No justification was given for the basis of quantization of the momentum of an electron. Bohr's theory could not explain the origin of observed fine structure of spectral lines in any atomic spectra. Line spectrum of hydrogen was discussed, but there is another fine structure of the spectra also. Okay, in that line spectrum inside there are another fine line spectrum also which is present, which was not able to be discovered or explained by Bohr's model of atom. Now moving on to the next question, that is question number 37. For the element with atomic number 24, so the atomic number is given already. 3 parts are there. Write the electronic configuration, how many unpaired electrons are present in it, and to which block of the periodic table it belongs. So the first part is write the electronic configuration. So atomic number is given as 24. Okay. So the easiest way to write is in this format. That is, till argon it is mentioned here. So what does that mean? That is atomic number of argon is 18. So you don't have to write 1s2, 2s2, 2p6, all of that. Till argon, that is till 18 electrons, it will be included in this argon symbol which is represented here. So that is 18 electrons are already mentioned. So now how many you require? That is 6 more electrons will give you atomic number 24. So that is 3d4 and 4s2. Right? Argon 3d4 and 4s2. So this is the electronic configuration of atomic number 24. Next part is how many unpaired electrons are present in it. How many unpaired electrons are present? So as you can see, 4s2, the s orbital is completely filled. S orbital can hold how many electrons? 2 electrons. So that is already filled. Now d orbital, let us see. D orbital 1, 2, 3, 4, 5. There are 5 d orbitals, right? How many electrons are there? 1, 2, 3 and 4. So how many unpaired electrons are there? 4 unpaired electrons are there, right? And of course it is a d block element because the last electron goes to the d block, right? Even though we have written it as 3d4, 4s2, it means that the last electron goes to the d orbital. Right, not the s orbital, because the s orbital is already completely filled. The last electron goes to the d orbital. So wherever the last electron goes to whichever orbital, that is the block. That is, if it goes to the s orbital, it will belong to s block. If it goes to the, that is, if the last electron of the element goes to the p block, that is p orbital, it will be under p block. Now here it is going to the d orbital, hence it is a d block element. Okay, so this carries 3 marks. I hope it is clear. Moving on to the next one, derive the relationship between Cp and Cv for an ideal gas. Okay, so this you have already studied in physics as well, okay, and in chemistry as well. So there is a slight difference in how you derive the equation. So let's see, heat constant at constant volume. Okay, so this is Cp and Cv. You have to find out a relationship between Cp and Cv. So let's begin with the equation that we already know. So heat at constant volume is given as, heat is Qv, right? Qv, that is at constant volume. That V is mentioned here. Constant volume is mentioned as QV. Q stands for heat and V stands for heat at constant volume, which will be equal to CV into delta T. So this specific heat capacity we have already studied. C is equal to Q by T. So this equation we already know. So from here we can derive Q is equal to C into T. So you can just rearrange. So that is the equation that we are using. Heat at constant volume will be equal to CV into delta T, right? Which is equal to delta U, change in internal energy. Now from where did that come? Change in internal energy is equal to heat at constant volume, right? This also is a known equation. So all these three we can write it together. That is delta U is equal to QV as well as CV into delta T is equal to QV. Clear? Now heat at constant pressure, QP will be what? The same way, Cp into delta T. Now what is delta H? Change in enthalpy delta H is equal to QP. So that is also a known equation. So we already know that delta U is equal to QV and delta H is equal to QP. So these two equations are written here. Now we already know this equation, that is equation for enthalpy, that is delta H is equal to delta U plus P delta V. So this equation is already known, and from ideal gas equation we know the equation, that is PV is equal to nRT. So we are going to consider for 1 mole of a gas, so N will be equal to 1. So that gives PV is equal to RT. So this PV is equal to RT. So you have PV here, which we are going to substitute by RT. As PV and RT is equal, in place of PV, we are going to substitute RT. So that is what is written here. Delta H is equal to delta U plus delta RT, which is written as delta H is equal to delta U plus R delta T. Now, why does this delta doesn't apply for the R? R is universal gas constant. It can't change, right? It's a constant value. So it is R delta T, which is shown here. Now we are going to take the delta U to this side. So we get delta H minus delta U is equal to R delta T. So I hope till here it is clear. Now we just have to substitute the values which we have already written. What is delta H value? We already calculated delta H value is Cp delta T, right? So that is written here, Cp delta T minus what is delta U value? It is CV into delta T, which is written here, H is equal to RT. Now, what is a common factor here? Delta T and delta T. So, we can cancel all the delta T. So, what is the final equation that you are getting? CP minus CV is equal to R. So, we got the equation. It's a very simple derivation which will give you 3 marks. Okay. So, I hope it is clear. Moving on to the next question. State Le Chatelier's principle. What is the effect of temperature on the equilibrium if the reaction is exothermic? So, the first part of the question is you just have to state the Le Chatelier's principle. So, if it is given in a question, state the law. Okay, any law it be. So, it is very important to specifically write that law. So, you can't write random sentences according to your choice. A law means whatever it is given in the law according to the scientist, that itself you have to write. Okay. So, it states that if there is a change in any of the factors that govern the equilibrium conditions of a system, then the system will undergo a change to reduce the effect of the change. So, what does that mean? If a system is in equilibrium and to that system which is in equilibrium, any other change is happening. Maybe we are changing the temperature, pressure, volume, any change is happening. What happens to the system? The system itself will try to neutralize that effect. That means if you are trying to increase the temperature for a system which is already in equilibrium, if the temperature is increased, the system itself will try to decrease the temperature. The temperature is decreased, the system itself will try to increase the temperature. So, I hope it is clear. So, that is basically Le Chatelier's principle. Now, the next part, what is the effect of temperature on equilibrium if the reaction is exothermic? Okay. So, if you increase the temperature, the position of equilibrium will move in such a way as to reduce the temperature again. Okay. So, it is given here what will happen to the equilibrium if the reaction is exothermic. So, reaction is exothermic means it is giving away heat. That means the temperature is going to increase. So, if the reaction is happening and the temperature is increasing, means what will happen to the equilibrium according to Le Chatelier's principle? The system will try to now decrease the temperature. Right? It is an exothermic reaction, so temperature is increasing. So, to neutralize that effect, the system will try to decrease the temperature. So, if it has to decrease the temperature, which reaction should it favor? It will be endothermic reaction, right? So, it will do that by favoring the reaction which absorbs heat. Okay, which absorbs heat. So, that excess of temperature which has increased, that can be reduced by favoring that reaction which will absorb heat. That means it will favor endothermic reaction. It will favor endothermic reaction. So, whichever side, that is whether forward reaction or backward reaction is endothermic, that reaction will be favored. I hope it is clear. Moving on to the next question. How are Kp and Kc related? Give one relationship in each in which Kp is greater than Kc, Kp is equal to Kc. Okay. So, what is Kp? Equilibrium constant in terms of pressure, and Kc is equilibrium constant in terms of concentration. So, what is the relationship between Kp and Kc? That's the first question. So, the relationship you have to write, that is that equation you have to write, and the terms you have to explain in detail. Okay. The next part is we have to write one example. Okay, or a reaction in which Kp is greater than Kc and Kp is equal to Kc. So, let's begin with the first part, that is the relation is Kp is equal to Kc into RT raised to delta Ng. So, this is a very, very important equation. Directly as seen in this particular question, directly they can ask you the relationship, and from this relationship you will get numericals as well. Okay, so Kp is equal to Kc into RT raised to delta Ng. Now, you have to explain each of the terms. What is Kp? Equilibrium constant in terms of partial pressure. That is this P. Right. Now, what is Kc? Equilibrium constant in terms of concentration. Okay. Now, what else is here? R. What is R? It is universal gas constant. What is T? It is temperature. Now, what else is there? Delta Ng. That is the difference between the sum of the number of moles of products and the sum of number of moles of the reactants in the gas phase. So, this particular part is very important. Gas phase. Only of those molecules which are in gas phase you have to consider. That is, in products and reactants, calculate the total number of moles. That is, calculate the total number of moles in products. Calculate the total number of moles in reactants. Take the difference. That is delta Ng. So, this G actually stands for what? That is, which are only in the gas phase. Okay. Now, moving on to the next part. When Kp is equal to Kc, you have to write an equation. So, the equation is H2, that is hydrogen and iodine combined to form hydrogen iodide. So, this is a balanced chemical equation. So, let's see. Kp is equal to Kc into RT raised to delta Ng. So this is the equation. Okay, so let's see how it follows. See, Kp is equal to Kc into RT. All of this is there. Delta Ng we have to calculate. So what is the number of moles in product? It is 2. What is the number of moles in reactants? Both of these are in gaseous phase. So number of moles here is 1, number of moles here is 1. So sum of it will be 2. So if you take the difference, it is 2 minus 2, which will give you 0. That means Kp will be equal to Kc into RT raised to 0, right? So any term raised to the power 0 will be 1. That means Kp will be equal to Kc, right? So of course this is an example for Kp is equal to Kc. Now next one is Kp greater than Kc we have to write. So here also let us see, all of them are in gaseous phase. So what is the number of moles here? 1 and 1. So total 2. Number of moles of products is 2. Number of moles of reactants is 1. Only 1 is there, right? So what is the difference? Difference will give you 1. That means Kp is equal to Kc into RT raised to, instead of delta Ng, it will become 1. That means Kp is equal to Kc into RT. So it is Kc into RT is Kp. So of course that means Kp will be greater than Kc. So these two examples you can mention for one Kp is equal to Kc and Kp is greater than Kc. So by this, we'll end today's session. So in the next session, we are going to discuss part D of the model question paper. So I hope the questions that we have covered in this session is clear for you. So that's all for today. Thank you.